Alright, so in this video I'm going to solve this question 8 where we have a region trapped between two curves and you're rotating it around x-axis and then y-axis, so you get two objects. So you want to find the volume of these two objects. Okay, right. So first thing you want to do is you want to find the intersection points because you're going to use them no matter whether you rotate it around x-axis or y-axis. Here I mean it's a question about both, so definitely you need intersection x points and y points. So let's find the intersection x points. So it's where you meet both curves. So now you square both sides because I want to get rid of square root x. So x is equal to x over 2 square. If you square both sides, square root x is going to be x. So x is equal to x square over 4. I take 4 to the left, so 4x equal to x square. This I can write as x square minus 4x equal to 0 by taking 4x to the right. And then I can factor x, so it's x times x minus 4 equal to 0. So x is equal to 0 or x is equal to 4. So this is 4, right? Okay, if x is equal to 4, then what's y? So if x is equal to 4, 4 over 2 is 2, so y is 2. So that's why I said by finding the intersection points. Right, now let's assume we rotate this region around x-axis. So it's going to be the x limits going from 0 to 4 pi, and you set it up with respect to x because you're rotating it around x-axis. Now what did I ask you to do in the previous problem? Draw two lines until you meet the function from the axis that you're rotating. So you're rotating around x-axis, so I'm going to draw two lines until we meet both functions. So which one is larger? The function on top. That's the first function we square. The function on top is square root x, so it's square root x square minus function on bottom is x over 2 and it's squared. So it's going to be pi 0 to 4 square root x square is x minus x over 2 square is x square over 4 dx. This integral will give you the volume of the object that you get by rotating this region around x-axis. That's it. I'm not going to solve it. I'm just going to set up the integral. Okay, right. Now let's assume you're rotating this around y-axis. So in this case, let's see, where's my example? Right. So in this case, we are working with the limits of y. So limits of y, they are going from 0 to 2 and pi dy, of course, because now you're setting the integral with respect to y because you're rotating around y-axis. Now what did I ask you to do? Draw two lines now from the y-axis until you meet both functions. See, which one is larger, which one is longer? The function on the right. But you can't use that because you have to change that function. Y is equal to x over 2 is x is equal to 2y. That's the new format. Write the function in terms of y. Make x subject. So that's the function that we square first. So 2y square because that's the function on the right with the longer radius. The function with the shorter radius is y is equal to square root x, but that's not good. We need to make x subject. So we square both sides. So y square is equal to x. That's the radius. Okay. So we square that second one. Y square square. So this is pi 0 to 2 4y square minus y square square is y to the 4 dy. This integral here will give you the volume of the object that you get by rotating this region around the y-axis. So that's the idea. Okay, that's the idea. That's how you set up the integrals. The most helpful thing to do, there are two things really. Drawing the radius, figuring out the radius. I always recommend you to draw that line from the axis that you're rotating. In the next video, you will see harder problems and you will realize why it is so important to draw those radius lines. Okay, and then the next thing is to, if you're rotating around y-axis, remembering and changing the functions to functions of y. Okay, just like I did here. Okay, right. So in the next video, we are going to change things a little bit because so far we only rotated stuff around the x-axis and the y-axis. That's all. Now, how about if we rotate these regions around a different axis? That is not necessarily the x-axis or y-axis. How are we going to set up the integrals to find the volume? Well, we'll learn that in the next video.